is that I will start by talking about 20 minutes on comparing a bit of industrial robots and collaborative robots. What are the benefits, real benefits of collaborative robots, and what are the limitations? Then Michelle will give you a few case studies from industry of Cobotic's use. And then Chris will talk about the research we are doing in the center and some case studies from our own research. And then we have about 5 minutes, hopefully, for questions. So let's get going. So industrial robots versus collaborative robots. And let's start with some heavy stuff. And this talk is not about ISO standards, but just a quick repetition on what's available. So in 2011, there were international standards were released on cobotics. And at that time, cobotics or collaborative robots was quite new. So they were pretty thin on details. They were introducing a lot of definitions, but they didn't really give any strict rules. And then in 2016, the technical specification ISO TS 15066 came. And in that one, there's much more hard data. There are formulas for sort of impact and formulas for maximum power and speed for robot designers. And it's also a much deeper investigation of the different collaboration techniques. And so one thing they talk about there, which is quite important, is the different collaborative operations. And the four types they list are the safety rated monitored stop, and that is mainly when a person is close to a robot, it stops, and when a person moves away, it restarts. And then the second class is the lead teach application or hand guiding, when a person works to teach the robot, but then move out of the workspace. The third one is the speed and separation monitoring, and that's pretty much the same as the first one, only that instead of stopping, the robot slows down when a person gets nearby and then speeds up again later. And then we have the fourth class, the power and force limited robots. So when you hear talk about cobots, it's almost always the fourth class here people are talking about. That is robots that are power and force limited to be able to work together with people and hitting them, colliding with them without causing significant damage to the person or injury. So although this is the focus now on cobots, I believe that this will change a bit in the future, and I'll get back to that in the end of this talk. So first, just some of the basic stuff, right? Cobots are supposed to be safe, and they're designed to safely interact with people. So this is just an example from one of my projects on pain relief, where I couldn't find a student to test it on, so I had to test it on myself, just to verify that it's all safe and good. And as shown here, I felt, very comfortable letting this robot hit me. It didn't hurt at all. Right? So cobots, the same as industrial robots, they are manufacturing high volumes, so relatively cheap. But they are not always the best choice for many things. So if you need high accuracy, high speed, high payload, large reach, or high stiffness, then typically a cobot will probably not be your first choice. And then a little bit more, how safe are they, right? So clearly, the collision impact will be highly dependent on the speed and the payload of the robot. And in the ISO TS, they do outline the maximum power and speed limits in power and force limited scenarios. And this was based on some pretty impressive study of the University of Mainz, where they really investigated how sensitive we are in different body parts for a collision. But for me, the only collaborative robot I would let hit my face is the one we saw previously. And the reason is simple. The payload of that one is only 0.5 kilo. So that it's a very different, even a 5 kilo robot, even in a body collision, it's not painless. Some of them are better than others, but there's definitely room for improvement there. So if you have the chance, if you only need to use a small payload, choose a robot with smaller payload, if that's sufficient. In addition, this certification is a little bit doubtful. In some cases, the Cobots have a different higher speed mode, meaning that the user has a potential to increase the speed above the safe limit, right? And that is a bit questionable, and that's only, it's different for different manufacturers. In addition, you see more and more combination when you add a Cobot to a linear track or a telescopic arm, and it's sort of highly questionable if someone has actually evaluated the combined speed of these Cobot systems. And as always, just because the Cobot is safe doesn't mean that the entire robot cell is safe. So clearly, if the robot has any tool that can damage you, the risk assessment has to be done on the entire system. So when we talk about the benefits of Cobots, what we typically talk is the shared workspace scenario, right? So as you see in these two examples, this is when we talk about Cobots, this is what most people envision: a person and a robot in a shared task, in a shared workspace. And the benefit here is that, if you're gonna automate something, because of this, we don't necessarily need to replace every little part of this task. The Cobot can come in there and do only part of the task. And because the Cobot can be together with a person, this works. So this really lowers the barrier for introducing automation. This shows a bit about how automation is highly dependent on the number of units. It's pretty obvious when you think about it. If you're only going to produce like 3 or 4 or 5 or a dozen of each unit, it's hard to beat manual work. People are really adaptable, can quickly change to a new task. And the same thing, if you're going to produce like billions of units, it would be worth typically to custom build a machine that can do this as efficiently as possible, right? So the room for traditional industrial robots, that's somewhere in the middle. An example would be like a car manufacturer, when you build a production line with lots and lots of robots, and then when you change to a new model, it's still flexible to reprogram it. You bring in a line builder who will reprogram this whole line, and then the same robots can be used to produce a different model. But if we look at many industries, the reason they would select a Cobot, it is not necessarily the shared workspace scenario that we mentioned earlier, but it's more sort of simple thing. The Cobot allows for faster commissioning time. It does have less space requirement, as you don't need to lock in, have a big cage that take up much more space than the robot itself. And it's also reduced cost. And this means that we're sort of lowering the barrier for introducing automation. So this curve here might actually look something like this. That's at least how I see it. Like, we allow the collaborative robots here, allow us to automate tasks that may not be sort of profitable even with a standard industrial robot. And going back to this, so the advantages of Cobots, we have the faster commissioning, less space requirements, and lower cost. And just for example, we don't need a cage, and that cage will occupy much larger space than the robot itself. So, and it's, we need interlocks. There's a long setup for this. So we do have a much faster commissioning, much lower cost. Sometimes this cage costs as much as the robot itself, and much less space requirements, right? Since Cobots are traditionally small, 5 to 10 kilo, there's much less, and they move at lower speed. there's much less reaction forces. So you typically don't even need to bolt the robot to the floor, which you need to do with a traditional industry robot. You may not even need a very rigid base. So again, much faster commissioning, getting started, and lower cost. Straightforward setup. So typically low-powered robot, single phase, no bolting, meaning that you typically don't need help to set this up. So that saves a lot of cost too, and time. And the robot itself, typically lightweight. So if you don't need to spend as much time planning and finding the sort of final position or setup for this robot, you can pretty much put it somewhere, getting started, and it will be quite easy to move it to a new location. And all this really speeds up the time to get started. Let's see what's happening here. So if you go back to comparing it to industrial robots, clearly there's quite a lot of difference, right? So we got this really big industrial robot. Industrial robots in general, large reach, large payload. And this is some extreme example, like the largest ones available. So this is the ABB IRB 870 with 800 kilo payload. So clearly, this is not something you can do with a Cobot. And this is not even the biggest one available. We got a Fanuc 1,000 kilo machine. And then we got the ultimate beast, the Titan, the KUKA Titan robot with 1,300 kilo payload. So this is quite different to what we see with a Cobot. Even though Cobots are slowly increasing the payload, there is a 35 kilo machine available. It's been around for quite a while. As you can see, the speed is very, very low to make it sort of safe. We see that both UR Robots and Omron have introduced 20 kilo machines quite recently with quite a bit, fairly bit decent reach. But still, right, comparing to like a traditional standard industry robot of 200 kilo payload, they're never going to reach that. It's never going to be safe to have that kind of payload or that kind of reach, which also leads to a much larger, heavier structure. Right? And we're definitely not going to see a 1,000 kilo payload collaborative robot. So reach has been increased in other ways. At the Australian Manufacturing Week now, recently, I saw quite a lot of examples of putting the Cobot on the telescope to increase the reach for palletizing applications. They're quite nice solutions, and it makes the Cobot more helpful. Useful. Another example from my lab, we have a linear track, also that to extend the reach of a Cobot. But again, it's easy to put a robot on a linear track, but then is it a Cobot anymore? Is it safe anymore? So these are things that really needs to be considered, right? Because you increase the combined speed, meaning you increase the combined impact of collision. So that really needs to be part of your risk assessment if you do this. Another thing, industrial robot, the speed. So here we got some really extreme examples of high speed industrial robots. We got a Delta robot from ABB doing like 2 picks per second. And then we got a SCARA robot here from Stoibli, the TP80. And I mean, it moves almost quicker than you can see, 3 picks per second. It's pretty impressive. And clearly, even if the payload is like very, very small, having something hitting you at that speed, it's never going to be safe, right? Industrial robot also have high accuracy and stiffness. And the stiffness is important too in many applications. And also to get this high accuracy, you typically need quite a lot of stiffness. Otherwise, you're going to deviate from your path due to the flexibility of the robot itself. So these kind of applications is hard to see in a Cobot. But that said, we do see a lot of increase in the maximum speed in Cobots. And I recently bought one of these, one of the GoFas, and it has like 2.2 meter per second maximum speed, and that's pretty impressive for a Cobot. And also one thing I'm pretty impressed with is the capacitive skin from Bosch that we see here, because this would allow us, since the capacitive skin senses a contact before it happens, a few centimeters before, meaning that it could really increase the speed and allow for a brake to reduce the impact. Even if it couldn't stop an impact, if you're running a really high speed, it would definitely reduce it, meaning you could run in much higher speed. So there is potential to increase the speed. Here, just out of interest for people that haven't really bought any Cobots themselves, I just put some prices for, this is from the last year, quotes have been given, and this is, of course, this is for me, this is university prices. Sometimes there's a discount. That's also highly dependent on which software options you get. But starting like a high price one, we got a KUKA, really high quality machine, but always 90,000 for a 7-axis robot. And that's not even the most expensive one. They have one here, the same model, but for medical applications, where all they've done is sort of limit the options of running it faster, and they increased the price to 125,000. Then we got ABB YUMI here, and it's quite a difference. We got 14 axes of these 2 arms, and we're down to 65,000. We got a Fanuc, also a high quality brand, been around for a long time, very advanced software. In this case, 60,000 for a 5-kilo machine. An Omron, the 12 kilo robot, fairly new one here, down to 39,000. The ABB is basically half of the first one, the YUMI robot. This is single arm YUMI, and we're down to 38,000. And then the one I bought most recently, the GoFar robot. It's actually only 33,000, which is a good price. And then lower payload Omron robot down to 28,000. And then we have the cheapest robot Cobot I've ever bought. It's the U factory from China. So this one is only 13,000 Australian, including the freight. So it's quite a big range here, from 90,000 down to 13,000. And quite often in the sort of higher the brands, the KUKA, ABB, Fanuc, what you get is there's much more advanced software available. So it depends a bit on your application. If you have a pretty simple application, you know, some of the cheaper brands might well be sufficient. Just a few words about the future of Cobots, the way I see it. So power and force limitation, it really is a major barrier to productivity in many applications, because many applications cycle times is key. You can't have a robot running much too slower than it could. So payload, reach, and speed, it's only really sufficient for quite a limited number of applications. You see also that the absolute majority of applications, we don't require continually shared workspace. It may be that we need to share with the workspace for a short time, but having the robot running super slow when 99% of the time there's no one close to the robot, that doesn't seem like an efficient use of your machine. So I believe that major growth would probably happen in this, may not be the power and force limited Cobots, but instead the other classes according to the ISO standards, safety monitored stops and speed and separation monitoring. So if you have you combine your presence monitoring device like a laser scanner or laser curtain, something like that, so the robot It runs in full speed when no one's around. It slows down. Immediately someone gets close to it, potentially stop completely, and then it resume working when the person leaves, right? So this, as long as you can trust your safety controller? Can you trust your scanner? This is really hard to beat, right? Instead of having this robot running slowly the whole time. There are some other issues. If you don't have a fence, it's not only that the robot could collide with you, the robot might hold something, it's moving really fast, and it actually something is released from the grip, it flies out of the cell, there's nothing to stop it, and it hits you. So there are considerations, but I still believe we're going to see a lot more of this in the next few years. And that's all from me. So I'm going to hand over to Michelle to continue talking about robots in industry and case studies. So
basically, I wanted to talk about different industry case studies of different robots. And the first one that I wanted to talk about was in the medtech field. And so this is a YUMI robot which was used during the COVID crisis. So we were looking at, or they were looking at, a Thailand university was looking at developing a vaccine. And that was obviously quite stressful for the lab workers, and they were working, 24/7 in order to get this vaccine out as quickly as possible. And so they used a YUMI robot to actually do a lot of the lab processing, and it was perfect for that application because it's got quite human-like movements with the dual arm operation, and so that was well suited for the the pipetting and the test tubes. So it worked really well for them as an option. And just to show you, this wasn't in isolation. I also found examples of ABB robots being used to develop vaccines in Singapore, in Thailand, in Italy, and in Taiwan. And then I stopped looking because there were so many. So that was a really good option, and it's really great for this kind of application because it's the Cobots are really quick to set up, and so it was perfect for this rapid solution that the world needed. The next one that I wanted to show you was in the agricultural field, and this was a sweeper robot used used to pick yellow capsicum. And so basically it's a Fanuc robot with a quite elaborate head on it, or quite elaborate gripper, that has then been connected to a scissor lift to allow it to go up and down. If we look at the video a little bit further on, you can see here it is going through the fields. It spots itself a capsicum, gives it a bit of a light show where it's taking lots and lots of images of it to determine its ripeness. And then it's got a gripper on the top that grabs the stem, has a little saw on it that cuts through the stem and releases it into the gripper, which catches it. And here you can see there's a bit of the vision system that it's got going on. It can actually create a 3D model of the whole vine to determine how the fruit are going, and then a vision system to determine where the ripe fruit are. And it works quite nicely through the fields there, doing its thing and capturing fruit. Also on the agricultural theme, and I won't spend too much time here, there were a couple of others that I wanted to share with you because I just thought they were really neat. This is an application where they're picking kiwifruit, and they can also pick apples. And you can see that the gripper actually sort of grabs the fruit and then sends it through this tube so that it's gently sort of lowered down to the hopper and down into the basket. And there's 4 grippers attached to this one robot, this one AGV, so it's able to work really quickly. Another one is this one here where they're picking tomatoes, and I really liked this one because it's really quick. Again, they've got a vision system to allow them to see when where the tomatoes are and if they're ripe. And then they've got this really nice quick gripper that sort of goes in, does a little spin, takes the tomato and drops it off where it needs to go. And that just really illustrates how you need to have a gripper that's really custom made for your solution a lot of the times. On to manufacturing, which is probably more interesting to most people here. And we've got a CNC lathe loading situation. So what I like about this particular situation is it shows how lightweight that robot is, right? They just wheel it in on a trolley. And then what I particularly like here is that they've mounted it, or they've placed it so that it's out of the way of the opening of the lathe. Okay, so you can see here, that the robot is out of the way. So if a human operator needs to get in there and have a look around or do something, they've still got that access without having to move the robot. And that's able to happen because this robot actually has 7 axes. So it's able to go around that corner. Here we've got it actually doing its job. You can see that it picks up the part from the completed part from the lathe. It goes and it puts it back in the tray. The lathe door closes and the machine does a self-cleaning operation. It puts it on the tray, and then it goes and picks up the next part and then takes that to the lathe. And it's all really nicely well timed. You can imagine that this would be a really boring job for a human operator, and the Cobot just does it effortlessly. Another example I wanted to show you was an assembly robot. I show this one to my students because I think it's a really good example of collaborative robots. They're making electric razors. And so basically this is the final operation where they are putting the final casing on, and the robot is doing the screwing operation. And that's a collaborative robot, an Omron collaborative robot. So the human operator puts the pieces together and secures the parts into the jig and the fixture. And then, I really wanted to highlight this, right? You can see here on the tabletop that the turntable is actually operated by the human, and the human has to use a 2-finger press in order to operate that. So safety is really important here, and this really just echoes what Matt's was talking about. The turntable itself is not safe. The robot may be, but the turntable isn't, and so we still have to implement those basic safety measures like the two-finger press in order to get the turntable to run. And you can see while the robot is doing the screwing operation, the human operator moves the parts around, removes the completed parts, and then puts the pieces in for the next screwing operation, and that works really well. Another example which is similar, which shows a collaborative situation, is you've got the operator working next to the robot. They're working in the same space. They're sharing the same area. Okay, they both operate in this central workstation. And again, I really want to highlight the safety here. There's a light curtain there that detects when someone has entered that space. And the robot can't go back in there until the human operator has actually pressed a button to indicate that they're not in there anymore. So you can see when he leaves there, he's actually pressed a button to indicate that it's safe. He's finished with that workspace and it's safe for the robot to go in there and work. So again, that safety consideration that you've got to consider when you're looking at collaborative robots. I really wanted to show you this one because I'm co-lead with Mickey on the quality assurance and compliance program, and this robot situation shows you how you can use the Cobot to actually do inspection as you go, which I really like and I think is a really good solution. This is a situation where we're actually looking at putting labels on a pallet machine or a palletizer, and it's a really tight space. And so the Cobot is perfect for that because as Matt's mentioned, you don't need to have a cage. You don't need that additional space. So the Cobot works in that really tight space. We can see here if the video starts. Are you not going to start? Okay, it might not start. Basically what happens is the robot puts a sticker on the palletizer. And then the interesting thing is it actually steps back, or it moves back from that sticker that it's just put on, and it uses cameras to take pictures of it to determine whether or not the sticker is first in the right space, and second of all, if it's legible, which is really important if you're looking at high speed, you know, getting your pallets out to the machine. Oh, thank you. We'll move on. And then the last one I wanted to show you was this packaging example. And really the only reason I wanted to show you this one is I wanted to show, it can be a bit hard sometimes to think what a Cobot looks like in your workspace and what it looks like on your factory floor. And so I really wanted to put this example in here because you can see the Cobot is just there, happily working, doing its thing. No one's bothering it. It's not bothering anyone. You know, it's just doing its job, business as usual. It's just another co-worker that that can't really talk to you. But I thought that was a really good solution, or a really good example of how easily it can be integrated into the workplace. And here it is, just happily doing its job. So that's all I wanted to show you, really. I will hand over to Chris.
Okay, thanks very much. I'm really conscious we're coming up towards the end of our time slot, so I might skip a couple of slides depending on how much I rabbit on about things. But basically, I think Mats and Michelle have given a really great introduction to Cobots and shown lots of great use cases in industry. What I want to talk a little bit more about is a little bit to do with the research going on, particularly in our centre, the Australian Cobotic Centre, and with our partners ARM Hub, the Advanced Robotics for Manufacturing Hub. I've got a few just examples of, I guess, what I would regard as successful examples of research coming from the centre and expertise from research, partnering with industry to solve problems and showing how Cobots can actually be deployed, and in some cases without a whole lot of effort to actually achieve an outcome. So I'll talk about a few examples from our recent or current work. So this, and I'm hoping I can play this video, not mute it. Is an example with colleagues from QUT and UTS as part of the Australian Cobotic Centre. They've been working with InfraBuild, who are steel manufacturers, essentially. They build and create particularly these metal rods, which you can see on the screen now. One of the things they need to do at times is remove rods from the conveyor belt as it's going through due to them not being long enough, or at least not meeting the need of a particular production line objective. And so that's traditionally been done manually, as in someone literally having to grab and throw away that rod as it's passing at some speed. Obviously, a better solution potentially is to automate that process and get the human out of the way so that it's safer and may even be even more efficient as well. And so, as you can see on the video, there's a Cobot solution being developed for this, where a sensor on the actual Cobot itself is detecting the actual rod to remove and then visually servoing down to actually get a gripper underneath it, a passive gripper. And in fact, this research was very much about the design of the gripper itself to meet the need of this particular task. And so you'll see here the system actually working in full, where it's actually going to select the rod that it needs to remove, and then it's going to come down and remove it. And I should say this is happening in the ARM Hub facility. So this is a facility that ARM Hub have for setting up test beds for Cobotic applications, where we can obviously develop and test and try things out. And that's very much what that's about. And so you'll see here this Cobot now about to pull up the rod, and not necessarily as gracefully as one might hope, but it's in many ways, that's the only way with a big rod like that, is to get it out of the way. And so this is ongoing work, and obviously there's more there to do, but that's a great example of solving a problem and demonstrating the Cobot being able to achieve that. The second example I wanted to talk about, again, this is work at the ARM Hub, our partners with UAP in this case. The UAP were tasked with linishing these metal sheets, and I'll just mute the music there. So obviously, as a manual task, that's quite labour intensive. In fact, it's estimated it takes about 24 hours to do one of these sheets if it's just a single person on the tools. But through a few days of work, collaborating with the company, working out how best to deploy a Cobot to actually help facilitate this, the Cobot was able to do the task with the human in 8 hours. So a quite substantial time save there. And obviously more than that, it's saving the labour intensive work, taking that away from the human operator, putting that onto the robot, but still having the human very much a part of it, because they need to swap over, for example, the sand belts, the lubrication that needs to be applied and things like this. So there's still very much a collaborative role here going on, but the Cobot's taking the manual task away and still working very closely with the human. So I think in only a few days, this was developed and they were able to meet the client needs that they had, which was to get about 6 of these done in a very short amount of time. So that's another really good example, again, of partnering with researchers and expertise to achieve an outcome for the partner. Another one here, this is a very different scenario. This is Again, this was with Arm Hub, working closely with a company called Consolidated Linen, who basically do large-scale laundry. So they do a lot of towel cleaning and then folding, and their ultimate goal is to automate the entire process. At the moment, they have some automation around the folding, but the towels itself have to be prepared first for that folding process. And so that was typically done manually. The project, however, looked at how cobots could potentially facilitate the same task. And so what you see here, and I think the nice thing about these examples is we're seeing different cobot scenarios. The cobot alone working, we've had the cobot and the human working, and now we've got two cobots working together. And basically what they're trying to do is get the towel to be flat so they can place it and then it can be folded with the machine. And that's taking the human out of what can be a very uncomfortable, humid, hot, noisy environment in a laundry. So this is the idea that the cobot can do that. That started way too early, but I'll move on to the welding example now that it's come for me. And this is the last example I wanted to show, which is with MTI Welding, another collaboration with Arm Hub. So these guys do welding for a lot of different clients, including big companies like Volvo. They actually had cobots available to them and were themselves doing a really good job at trying to program the robot to achieve what they're showing here. However, they did not quite have the full expertise required to finish the task. And so they then paired up with an engineer from Arm Hub who was able to come in and within one day have this actually doing the task. And then within 2 days was able to teach the staff there, the staff member, to do the same sort of programming. So I think what this is a nice example of is where in many cases, the companies are actually in a position to almost achieve it on their own, but may just need that little bit of extra help to get there to the end. And so the entry point for cobots in certain scenarios like this may not be as big as it may be considered. And I think that's a really important fact about getting the expertise involved and seeing the scenario, which is what we do in the centre, is very much come out and see where are the opportunities to potentially augment what's going on and provide the expertise and potentially the training to do it yourself as well. Now, I'm running out of time, so I'm going to just jump into probably what will be my last slide. As a centre, so what I've shown you there is some really good, very specific examples where research and industry have partnered to solve, very particular problems. But of course, we're all about the big picture and we want to see cobots scale up. We want to see them in manufacturing settings, being embedded with human workforces, working seamlessly. And of course, that doesn't just happen. And we've seen, there's been a lot of good highlighted challenges and safety concerns, lots of things. And so when we consider this as a center, we have to consider the whole part of what makes, what is the success story for cobots? What does that need? And so these programs which you see here are all the programs that the ACC has research going on in. And I'll just quickly go through them. We've got the biomimic cobots. Obviously, a lot of the tasks we're trying to do are done already by humans. And so there's clearly things that we would like to be able to replicate in the cobot to perform it. Now, that could be done programmatically, but ideally we would love it that we could even have cobots learning from human demonstration as well. So that kind of research around the perception systems involved, the learning theory for that to occur is very much part of the research in that field. Human-robot interaction is an absolute given. We're talking about collaboration between humans and robots, so that's clearly interaction. And that's, that's about the interaction design, but it's also about the more nuanced cues and the ways in which we, as we saw in some of those case studies that Michelle showed, ways in which we make sure that the robot is performing what it needs to when it does, and then not when it's aware that there's a human in play. Lots of interesting questions there that need to be thought about and ways to deal with those sort of complexities. The larger picture, so that human-robot interactions about humans and robots sort of together working, but let's put it in the larger scale of a whole manufacturing system. How do we know where to put cobots? Where should we put cobots? What sort of space requirements are needed? All those complexities, which again, those case studies showed plenty of diverse examples of. Understanding that system is also very much a part of what our research needs to consider. How best to deploy cobots and what's the requirements for working with humans in that setting. Quality assurance and compliance is another program. I mean, if we were just talking about manufacturing, we'd have this topic, but we're talking about with cobots, we're sort of adding that level of complexity where we've now got systems in play that are, derived from AI systems as well. We've got to make sure that we're still tracking the quality and making sure that if things aren't going as they should be, that we know why, and we can trace back and have the systems in place to understand that and then fix it. We need to understand what the system's doing. So that's all part of that branch. And the last branch, which I think is a really fascinating one, and it's not just about cobots. I mean, we're already seeing AI and very recent news and topical information at the moment out there around AI and how it's augmenting our work and what we do. Cobots are, of course, an instantiation of that. What's the new workforce? How do we handle that? How do we use that? How do we adapt and make sure that the jobs that we're defining for people are utilizing that technology? How do we ensure that there's health and safety all being covered? How do we make sure that the training required is there as well for the workforce of today and then obviously into the future? So I'm running out of time. So I had one more slide, but I won't try and cover all of that. So I'll just jump to what I also wanted to do. So we at Swinburne, we've been talking about cobots and we're really keen to talk more about it. We've got an event, Encounters with Cobots, coming up on July 5th. In our lab, so Matt's lab that he talked about earlier, we've got our cobots ready to show you and for you guys to come in and have a look. So if you're around, the Hawthorne campus and you want to come in, it's 3 o'clock, July 5th, and we'd love to chat to you and also talk to you about potentially how we can work with you. If you're an industry partner, potentially, or a company interested in cobots, we can certainly talk to you about how we might be able to engage and talk some opportunities there. So with that, I'll say thanks. And hopefully we've got at least a little bit of time for questions. I'm not sure, but over to the hosts.